An expression is a collection of numbers and symbols connected by operations. Not just any string of symbols, it's a mathematically meaningful statement describing a sequence of operations that are to be performed in a particular order. The order is determined by a convention that applies universally to all expressions. Brackets are done first, from the inside outwards, then exponents, then multiplication and division in order from left to right, then addition and subtraction, also from left to right. If you put two expressions next to each other with an equal sign between them, then you've got an equation. You're saying that the two expressions are equal to each other, which is to say that they have the same value. Now you might not know what that value is yet, because there might still be some variables whose values you don't know. But you are asserting that the expression on the left and the expression on the right have the same value. Please be very careful with that equal sign. Many people misuse their equal signs. It's a mathematical symbol that has a very specific meaning. Literally, has the same value as. This is the only meaning this symbol has. Don't use it anywhere else. It doesn't mean therefore or here's the next step. That's a bad habit some people get into from primary school. There is a symbol for that. It's the 3 dots in a triangle here. That means therefore. The equal sign does not mean therefore. It also doesn't mean here's the answer. That's another bad habit I see in my students' work. Use words to indicate the answer. Write a sentence to explain and interpret it. Don't just leave an equal sign hanging out in the middle of nowhere. The only place an equal sign should go is between two things that have the same value. If you can't replace the sign with is the same as and get a correct, meaningful sentence, then don't put an equal sign there. Now suppose I give you a verbal description of a problem. Can you write a mathematical equation to represent it? I had $35 in cash. First I spent some money on a dress for my wife, and then I got out another $20 in cash. At the end of the day, I had $38 left. How would I write that using mathematical symbols? I had $35. I spent some money on a dress, but I don't know how much. I got out another $20, and I ended up with $38. Now, I don't know how much the dress cost, do I? Although you can work it out from this equation, yes. That's where we'll be going next. But what have I done to represent the cost of the dress in the meantime? I drew a dress. It doesn't actually matter what you use there. You could use a giant question mark, or you could draw a box. You could even use a flower pot. It doesn't actually matter. You can use whatever symbol you like to represent the cost of the dress. But drawing a little picture of a dress, or a flower pot, takes quite a while, and I'm a lazy mathematician. I don't want to waste time drawing unnecessarily detailed little pictures every time I write an equation. So I tend to just use a normal English letter. Let's say a D for dress. It doesn't matter what symbol you use, but we tend to use normal letters because they're easy and quick to write. Did you work out the cost of that dress, by the way? Let's try another. I started off with $200. First I bought a shirt, and then I bought a pair of shoes worth $80. I had $60 left. I started off with $200. I bought a shirt, but I don't know how much that cost, so let's just use a little picture of a shirt to represent it. Then I bought a pair of shoes for $80. At the end, I had $60 left. Again, it doesn't actually matter what symbol you use to represent the cost of the shirt. If you don't like drawing little pictures of shirts, you could just use a question mark or a box. Or, as most mathematicians do, you can just write a normal letter instead, which is quick and easy. Let's use an S for shirt. Can you work out how much I paid for that shirt? Can you work out the value of S? Another one. Justin had 2 chocolate bars with the same number of pieces in each bar. He ate 13 of the pieces. This left him with 43 pieces of chocolate altogether. 2 chocolate bars minus the 13 pieces he ate, leaving 43 pieces. And again, because it's easier than drawing little chocolate bars, you could just use a letter like C to represent the number of pieces in each chocolate bar. Can you work out how many pieces C is? Can you solve this equation for C? You can do the same thing with more abstract problems too. Here are some mathematical who am I questions for you. When I multiply a number by 3 and add 7, the answer is 13. What's the number? If we're going to write an equation, we need something to represent the number, whose value I don't know. Let's use n for number. If I multiply the number by 3 and add 7, I get 13. Can you see what number I had to start with? The number is 2. If n has the value 2, then 3n plus 7 is 3 times 2, which is 6, plus 7, which is 13. n equals 2 is the solution to this equation. What about the next one? When I divide a number by 4 and then add 12, the answer is 14. Let's use n again for the number I don't know. When I divide the number n by 4 and then add 12, I get 14. I don't need brackets here because the divide happens before the plus. Okay, can you see what number I had to start with to make this equation hold, to make this mathematical statement true? The number I start with has to be 8. 8 divided by 4 is 2, plus 12 is 14. The value of n has to be 8. n equals 8 is the solution to this equation. One more. When I subtract 7 from a number and then multiply by 6, the answer is 18. So again, using n for the number, I subtract 7 from the number and then multiply by 6 to get 18. I need brackets this time because I want the subtraction to happen first before the times. So, what value of n makes this true? Well, 3 times 6 is 18, so n must be 7 more than that. n has to be 10. Solving these simple equations just by looking at them and using quick mental arithmetic is called solving by inspection. You just inspect the problem and see the answer. But if the equations get much more complicated than this, we're going to need a more robust method that we can rely on.